Hey, thanks for stopping by. Robert Kofed with Computer Creations, and today we're going to talk about how to check the timing on your Galvo laser. What is timing? A lot of people might not know what that is, so let's talk about it for a minute. Timing is very similar to a scan offset setting on a gantry CO2 laser. If they're not set properly, you're going to get substandard results on your products. And so timing is basically just the time it takes from the laser to fire and how the mirrors react. And if the timing is set properly, you're going to get a very specific result. If they're not set properly, you're going to be able to tell that, and I'm going to show you how to determine that today. The materials that we're going to need are black aluminum business cards. I'll put the link in the description. The other thing that we're going to be using today is a USB microscope. Now, these are about $40 on Amazon. I'll put that link in the description as well. But this is a tool that you really need to have if you own a Galvo laser. And the reason being is the pattern that we're going to design in LightBurn and then check our timing really can't be looked at just with the naked eye. You're just not going to be able to do it. And so, at first I was using my phone where I would zoom in on a picture, and that kind of worked. But trust me, if the difference between that and using something like this is a night and day difference. And so if you've got a machine like this and you want it to operate in tip-top shape, these are the tools that you're going to need. Now, this video is sponsored by Houghton Laser, and they provide initial timing in your profiles when you upload that information into LightBurn. But it's always good to check that to make sure that that's exactly what it needs to be. And so I'm going to show you an illustration first, and then we're going to jump into LightBurn, and I'm going to show you how to set this all up. We'll start engraving some shapes on black business cards, and we're going to check that under the USB microscope, and we're going to see what we need to do from our settings in LightBurn. The design that I'm going to show you on a piece of paper, this is what confused me at first when I was trying to kind of wrap my head around what I was doing. And so basically what it is if you generate a rectangle and you want to engrave that rectangle completely, usually you're setting your DPI or your LPI, your lines per inch, to so many LPI. It might be 400, 600, 1,000. And so what that means is that you have 1,000 individual lines going back and forth in that predetermined rectangle. And that's what I want you to kind of keep in mind today. Our LPI numbers are going to be very, very low because I only want just a few lines in that predetermined rectangle that we're going to generate. So let's jump into the illustration. I'll show you what I mean. I'll show you what we're looking for. And before you know it, you're going to know how to time your Galvo and make sure that you are kicking out just absolutely perfect products. Step one, when you're trying to check your timing on your Galvo laser, is to set up the pattern that we're going to generate. And so our pattern size is going to be 1 inch wide by 0.7 inches high. And we're going to create two different rectangles on two different layers. One is going to be set to line, the other one is going to be set to fill. Here are my settings for my 15-watt Galvo laser. So we have 100 millimeters a second speed, 40 frequency, Q pulse of 1, and that is line. That's actually going to just generate the perimeter. So if we preview this, you're going to see that that'll get our perimeter scored. Then we're going to create a second rectangle that's in fill mode, same settings, 141. And normally, this is what I wanted to talk to you about, because this concept is critical. Normally we would be setting our lines per inch 3, 4, 5, 600,000, just depends on what kind of work you're doing. And if we did that and we previewed that, you would see that we would fill in this rectangle, and the laser would go back and forth, back and forth, back and forth. at 400 lines per inch, and that would be, you know, the engraving. Well, in order to check our timing, there's way too many lines here, and I can't check the intersection of this horizontal line with this vertical line. And so what we're going to do is we're going to take this fill layer and we're going to change that lines per inch down to like 6 lines per inch. We're going to make sure that our crosshatch is off and our bidirectional fill is on, and we're going to say OK. And when we preview that, you're going to see that we only have a handful of lines here. If we take this and we hit the letter P and put it right over the other box that's centered, now if we go ahead and we preview these two together, we're going to have a box with horizontal lines. And to check your timing, you know, let's talk a little bit about how your laser works. So it turns on the laser here and it goes across, and it turns the laser off. Then it comes down here, turns the laser on, turns the laser off, comes down here, and so on. And so the timing, when you're talking about timing on a Galvo laser, these are the critical points right here. So this intersection of this horizontal line and this vertical line, we're going to be engraving this on a black metal business card, and we're going to be looking under the microscope for this intersection right here. And in a perfect world where you've got your timing set up right, this should intersect, and I'll put up some pictures here for you on kind of what you're looking for. And so depending on if the timing's right, this intersection should be very good, and I'll show you. If the timing's not right, what's going to happen is you're going to see a gap right here. I'll throw up a picture so you can see what that looks like. And the gaps will show up on either side because it depends on whether your laser is turning on or turning off, depends on where this gap is going to be shown. So you're going to be wanting to look at these two intersections. Now the other thing that we're going to check today is how square our corners are. We'll leave that to later in the video, but what we're going to do is we're going to design this layout. So we've got two layers, one is line, one is fill. The fill layer, we've turned our crosshatch off, make sure that's off, your bidirectional fill is on, and we're going to turn our lines per inch way down so we only have a few lines to look at instead of hundreds. And then at this point what we're going to do is we're going to preview this, we'll send this to the laser, it will burn this pattern, and then this is the pattern that we're going to look at under the microscope. Okay, we've got our design created for our test pattern, and so what I wanted to do is show you where these settings live. And so I'm going to come up here to the wrench icon, click on that, we're going to open that up, and this is your lens profile. So this is for my 210 millimeter lens. You can see that we've got all of our adjustments here. Again, these typically come from the profile that was sent to you via Hotian laser, and you would just inputted or imported these numbers. And the numbers that we're going to be working on today is our delay defaults. And remember when I was describing that, you know, it would turn the laser on and then it would turn the laser off? Well, these are all the numbers that we're going to be dealing with today. And what I thought would be helpful is I pulled up the definitions from the LightBurn software on what these numbers mean. And so, as remember when we talked about it, the laser is going to turn on and generate a horizontal line and then turn off, come down and back and forth, right? So the things that we're looking for is the intersection of the horizontal and the vertical lines. And so this very first one, TC, laser on TC, microseconds the laser will wait to fire after the mirrors begin to move. Too high a value will leave gaps. Too low a value may cause excessive burning at the start of the cut. So this is actually at the very beginning of this. So if the laser's coming this way, it would be right here where it starts to generate that horizontal line, and that this laser on time would have to be adjusted. Okay. On the flip side of that, you have the laser off, microseconds to delay turning the laser at the end of the marking move. Too high a value may cause excessive burning at the ends of the cut. Too low a value may cause gaps. Okay, so we have to look at the intersections both on the left-hand side and on the right-hand side when you get this engraved into that business card. And depending on whether it's on the left-hand side or the right-hand side will depend on which one of these on or off adjustments you need to make. But if you want to look this up, if you just go up to into your help section when you're in LightBurn and go to online documentation and type in laser on TC, it'll take you to this section. And this will give you kind of a guideline on what you're seeing versus what you have to do with these numbers here. Okay, so that's the laser on and off numbers. The polygon, the one on the bottom here, has everything to do with how sharp your corners are. When you engrave this pattern, you should have a nice sharp corner. And so if you don't, you will be able to adjust these Polygon TC numbers to get a sharper corner. And so that's the other thing that you're going to want to check today. The NTC, that has to do with the speed in which your laser does things, and we're probably not going to get into that today. That's another very in-depth process. We're just going to worry about the timing for the laser on, laser off, and the polygon. We're going to get that handled today, and this NTC will probably have to be a separate video. So let's go ahead, and now that we know where the settings are that we're going to have to adjust, what I'm going to do is I'm going to change these settings and show you what a poorly timed Galvo laser looks like and what you're looking for, and kind of how to get it dialed in. So that's next. What I've done is I've opened up our lens calibration screen. Remember that it lives right under the wrench icon. And you remember that my settings were -200. I've taken that laser delay on and I've cranked it up to 1000. And what I've done is I've engraved that pattern, and we're going to look at it under the microscope so you can see kind of what you're looking for. I'll show you what it should look like first, and then I will show you what it looks like with this setting here. And this is going to be just the laser on. So the result is going to be on every other line, because remember, as it will turn on, turn off, come down, turn on, turn off, come down, turn on, turn off, if you have your bidirectional fill turned on. So let's go ahead and jump over to the microscope and I'll show you what I've got. Okay, here we are at the microscope, and what I thought I'd do is I'd show you what it should look like when you're all done. So these are some of the settings that I ended up with. All you're going to do is you're going to just put this under here, and you'll see how much this microscope shows. Okay, so these lines, you can see what I'm looking for is this intersection right here. This intersection right here, it should be nice and clean. There shouldn't be any bulbs out here, any things that look like a circle. You want to make sure that your horizontal line, let me get a pencil, your horizontal line comes into your vertical line and that it's clean, that there's no gaps there. And so remember, because it's coming across and then it's dropping down, you not only want to look at your left side, you want to look at your right side. So as we go further down here, we just want to make sure that all of the ones on the left and right sides come into that clean. Okay? All right, and then if we come over to the other side, because remember, you're going to have on and offs on both sides. It should be the same. We'll follow it along here. You can see that they're all nice and clean. They're not tapered in any way. They're not rounded at the ends. If they were rounded at the ends, that you would have to change your settings. You can see that they all come in nice and clean. Okay, even the last one. So that's what they should look like if your settings are right. So remember that I turned my TC on way up to demonstrate kind of what you're looking for and what you would need to correct if you find it. So if we come down here and we look at this one here, okay, you can see that there's a gap there. So it's obvious that the laser is coming this way and turning on, and the delay is too great. It's too much delay because you see this big gap right here. And so what that would mean is, remember, I just put in 1,000 delay and I was at minus 200. So you can see that I would need to reduce that timing delay to get that so the laser starts faster, so you don't get this kind of a gap here. This is what can really mess up if you're doing pictures or any really finely detailed work. This will raise havoc. Now, when we come down to this next line, it's going to be fine because that is the turn off line, right? So that's fine. But if we follow it over, you're going to see that we're going to see the same gap on this left-hand side. Bear with me here. There you go. So see, you've got a gap here. So what it did is it started on that upper line, started, turned on here, turned off, came down here, turned on, and you can see that that our turn on, our turn on needs to be adjusted. So that's a great example of where your timing delay is too great, and you need to reduce that timing delay to make sure that the laser is starting when it should, and you get nice, clean horizontal and vertical lines that meet each other. So that's the laser on. Now, what we'll do is I'll go ahead and correct the laser on, and then and I'll change the laser off, and you'll see that this very first line that's clean now, this very first line is great now, but I'm going to intentionally put in a delay so you can see that this is, because this is the turn off, right? So we turned it on the left-hand side, and that delay was too great. We've got to fix it. Okay, it turned on here, too big a delay, but the turn off delay was fine. And so I'm just trying to take a little time to make sure you understand kind of the philosophy behind how this works. And our turn off delay is set perfectly, but I'm going to intentionally change that so you can see how that works. Okay, so let's talk about our laser off TC. Okay, mine typically was set at 100. I've reduced that from 100 to 0. And let's take a look and see what that's going to do. So if the laser started on the right-hand side and is going to the left, we should see this first line. We should see some difference in this first intersection down here. The other thing that I will tell you that I've changed, and I want to make sure that you guys are aware of it, I increased my speed to get a little bit finer line. So my settings I've changed just a little bit from 100 millimeters a second to 300 millimeters a second, and it just shows these adjustments a little better. So be sure you can start with this setting here if you've got a 15 watt UV. 300 millimeters a second instead of 100 probably will show you your adjustments just a little bit better, so be sure you make that correction based on what I indicated earlier in the video. And so we've taken our laser off TC from 100 down to 0, and let's show you what it looks like. Adjusted our laser on time, and we're messing with our laser off, so it comes laser on, off, laser on, off, back and forth. And so what we're looking for is this first one down here. Okay, there's the line. Let's see if we can find, okay, so there's the top. So if we go down just a little bit further, boom, there you see. So you can see this gap right here. Remember, it turned on to the right, it's going left, turn off, and remember I took my setting from 100 down to 0, which means I reduced my delay, and we need to increase the delay so this line gets engraved all the way into this vertical surface. And so the philosophy is pretty much the same on either laser on or laser off. You want it to, you know, come in here cleanly for sure. And so you would increase that. We're standing at 0 right now. You'd want to go, you know, you just want to start taking small increments until you get a nice clean line. And you can see that if we drop down below, the next one down is going to be fine because that's the laser on one. Remember, we readjusted that, and that one looks fine. But if we follow it all the way across, where we see the laser off, sorry for the jerkiness, this microscope's sensitive. And you can see that my speed is not set quite right, but the bottom line is you can see that it's not done very well. I need to slow down the speed a little bit. But there's a fine line on getting this to where it'll show it to you well. Just a thicker powder coating right there or something. Here's a good one. There. You can see this little bitty gap right there. Okay. So laser's on coming this way, and it's going to turn it off here. And we need to adjust that delay so this horizontal line comes cleanly into this vertical line. And that's really, when you're talking about laser TC on and off, that's exactly what we're looking for. And once you get the real clean lines on both, then you can move over and move on to the corners. Let's take a look at that right now. I haven't adjusted my corners in any way. So you can see that, let's take a look at this corner, and I'll play with the adjustments, and we'll see if we can get that a little sharper. Okay, so I thought it would be easiest to show you the results. What we were doing is we were playing with this Polygon TC number, and this has everything to do with the cleanliness of your corners. And so what I did is I left all the rest of these delays alone. They're dialed in. And I changed this Polygon TC from 80 to 110 to 400. And you're going to see the different results. So let's take a look at this one right quick. And what we're looking for is a nice clean corner. Now you're not going to get a true 90-degree corner, especially on the outsides. On the insides it's a little better, but what you're looking for is as much of a 90-degree corner, smooth as you can be. You don't want any bulbous effect or any rounding of this corner on the outside. And you know, every lens and laser is going to be a little bit different. My setting is between this 80 and 110. My setting is at 100. That's what I've chosen. And you can see that we've got a real clean corner here. No artifacts to speak of. But when I cranked it up to 400 to kind of over illustrate what you're looking for, you can see that this one here, we start to get a bulbous effect. And what's going on is that laser has stayed there just a little bit too long, and it starts throwing a round beam signature out here. And if you were engraving using this setting and you were engraving a lot of detail, it would really destroy the quality of your product because of these corners. So this illustrates pretty well why you would need a USB microscope. But the good thing about this, once you do this for each individual lens that you have, you know that Galvo laser is going to be as good as it gets. And like I said, most of the ones that I've seen, both my, the ones that I've seen have been right around 100. But You know, if you're seeing things that aren't a nice smooth transition, go up or go down, and you'll see where it'll get better or worse. And just play with it. You'll just order a pack of the black business cards and take a couple of hours and do this. And trust me, when you do this, you've just learned so much more about the settings of your Galvo laser. And away you go. There's one other thing I wanted to cover that's really kind of a bonus. You know, you're going to do this for each individual lens, and all this information is pretty critical to the operation of your Galvo laser, and it needs to be saved somewhere safe. So what I will tell you, LightBurn makes it so easy to save all this stuff in one option. So we're going to come up here to File, we're going to go down to Bundles, we're going to say Export Bundle. And this is where you can back up all of your settings, your hotkeys, all of your laser profiles for all of your different lenses, and also all your material libraries, all your art libraries. The great thing about this is if I export this to a safe place that's on a solid state hard drive or out on the cloud, all of these settings that we just determined will be safe. And so if for some reason, God forbid, your hard drive goes bad and you don't have the ability to retrieve this information, you could reload LightBurn, get into the new LightBurn and come into bundles, come to import bundle, go to that saved file that you have, and it'll bring LightBurn back to exactly all the different settings that you had before you had a problem. So please do that on a regular basis. I do that every couple of weeks because I'm always adding to my material list and my art library and that kind of stuff. And it will save you a whole bunch of work if you don't do that. So I want to thank Haotian Laser for sponsoring this video, and I hope this information was helpful. If you enjoyed the content, I'd sure appreciate a thumbs up. If you haven't done so, subscribe. Sure appreciate it. Until next time, thanks and have a great day.